Hello my dear, welcome to IMS GATE Academy. I am Sourav Upadhyay, and in this session we are going to discuss the fundamentals of network models. My dear friends, industrial engineering comes to a total of around 4 to 6 marks on an average, and if you have to do good in that, we have to be very good in network models, as you know that it is one of the most important chapters as far as industrial engineering is concerned. So keeping that in mind, I will be addressing the basics of network models in this session. My dear friends, what can you expect from this session? In this session, apart from discussing the basics of a network model, I will also tell you that how to actually do the calculation in a network model by taking a complete question as my example. There I will be telling you different ways of evaluating the network, how to find the float, how to find the slack, and eventually it will lead to the critical path of a network which you know or which you have studied. So my dear friends, so very good afternoon Mr. Gopal Rao, and so without wasting any time, let us start today's session. Right. My dear friends, a network model is all about events and activities, right? But before that, you can already see that I've represented a node, means I've represented an event and I've represented an activity. But before that, what is an event and what is an activity? We should understand that. Now see, few 1 or 2 days back, IPL got over, and I'm sure that everyone must have enjoyed that. Now in an IPL, when I say that a tournament is starting, IPL is starting on a particular date, IPL is ending at a particular date, and between those dates matches are taking place, right? Group stages are taking place, qualifiers are taking place, and then finally the final event is taking place. So when I'm saying a particular tournament is starting, that is an event. When I'm saying a particular tournament is ending, that is an event, and whatever things are happening in between these two dates, these are the activities. So my dear friends, if I say that a complete IPL, if I'm representing IPL as a project, an entire project, so that is made up of events and activities. Now what can I say as an event? IPL is starting, or group stages are starting, group stages are ending, semi-finals are starting, semi-finals are ending, or qualifiers, whatever you say, final starting, final ending. So tell me one thing, IPL is starting, is it consuming any resource? No. If I am saying that IPL is ending on this particular date, is it consuming any resource? No. So what is consuming? The matches which are taking place in between, these are consuming the resources. By resources you can time and money, these are your resources. So whatever is consuming your resources, that becomes my activity, and whatever is not consuming the resources, that is your event, right? So here you go, event are represented by nodes and activity is represented by arrow. This activity is going to consume resources, therefore I have written time t which is required to finish this activity, and these are the nodes or events. This is the head event, this is the tail event. You can clearly see event is represented by node, activity is represented by arrow, and in a complete project, so many activities, so many events are there, and that is our purpose, to evaluate an entire network diagram. I hope you have got the difference between event and activity. So I can say that event does not consume resources, an activity consume resources. Right. So my dear friends, you can clearly see that there is a project in front of you, and here are so many activities, here are so many nodes, and we have drawn that. Now you must be wondering that, sir, what is our purpose over here? Yes, I have understood what is the project, event and activity, but what is our purpose? My dear friends, your purpose is to find out that what is the minimum time. You must be wishing for that, what is the minimum time. Everyone wants to do a project in as less time as possible, right? Why? Because resources are very much limited. You don't have unlimited resources available with you. So you want to find what is the minimum time in which you can complete this entire project, right? So for that, or you might also be thinking that, sir, what is the minimum time by which I can I can go from one event to other event, or what is the relaxation time which I can get in doing a particular activity. There are so many angles while when you analyze a network diagram, and this is what exactly is our purpose, this is exactly what is our agenda, that we will be analyzing what is a what is the minimum time, and then what is the slack of an event, what is the float of an activity, what is the relaxation time we have got in doing an activity, and so on and on and on, right? Fine. My dear friends, that is fine. That is the latter part of the discussion. But first you should know that how can you draw a network diagram. That is the most important thing. If you don't know how to draw a network diagram, then this discussion becomes useless. My dear friends, there are various types of event that you can see. Suppose this is an event. Now you know that event is represented by a particular node. So see, here all the activities are coming on this node. So this is called a merge event, right? When all the activities are going out from a particular node, that is called a burst event. And in a particular node, when activities are coming, activities are leaving, so this is known as merge and burst event, right? Or you can also say it is a dual event. I can also write that it is a dual event. Fine. My dear friends, for drawing a network diagram, there are two ways. First, I can represent activity on arrow, where you can see that A is an activity represented on arrow, C is represented on arrow, and the second method is activity on node, where A is represented on node, B is represented on node, and right. My dear friends, as far as your exam GATE is concerned, 99% of the times you will be getting, or you have the freedom to use activity on arrow. This is mostly used, right? But what about activity on node? Activity on node, I am not saying it is not important. It is important. In fact, questions have come, but you will not encounter this as much as activity on arrow. That being said, this is, you should also know how to draw this. You should also know how to draw this, and for that matter of fact, I have given this as an example. Right? You can clearly see that how activities I have represented on node. Fine. We will see that later. My dear friends, now quickly let's come to what are the rules for drawing the network diagram. What are the rules? So clearly you can see I have written, just to save your time, that a network diagram should have unique start and unique end. It means in a network diagram, you will have one start and you will have one end, right? Second is, common start and end are not allowed for two activities. Now this is the most important rule that you should take care of. Common start and end are not allowed. What does this means? This means that, let me try to give you an example. Suppose in a network diagram, this is these are the two events. Let's say this is event 1 and let's say this is event 2. Let's say you have drawn this activity A having some 3 days of time or 3 time units. Now you cannot draw an activity B which is taking some time to get completed and it is having a common start and common end. This is not allowed. This is not allowed. Sandeep, I will come to your question, but first let us discuss the basics of network diagram, then I will address your question. See, what I am trying to say is that this is not allowed. It means that these two activities are having a common start and a common end. This is not allowed. And if this is not allowed, what is the way further? The way is you have to introduce dummy activities. You have to introduce dummy activities. This is where dummy activities comes into picture, right? So let me show you how to draw this. See, now this I have drawn a dummy activity D1. Why I have drawn a dummy activity? Because this is not allowed. So always keep in mind that if this is not allowed, the only way is whenever you are having problem in drawing a network diagram, dummy activities will rescue out of that problem. Now you will be asking that, sir, can I be using as many as dummy activities as possible? My dear friends, you should always use as less dummy activities as possible. Why? Because you don't want unnecessary, unnecessary dummy activities in your network. It will unnecessarily complicate the diagram. Anyway, fine, this is done. Second, looping is not allowed. Now what is looping? Looping means, my dear friends, I'll show you one diagram and you will understand it. Let's say this is 1, this is 2, this is 3. This is a looping. This is not allowed. Clearly you can see that this network diagram is are there in a loop. So this is not allowed. This is completely not allowed in a network diagram. Now let me give you another example to show you that my dear friends, this is not looping. The one that I have drawn over here, this is not looping. This is totally allowed. I repeat, this is totally allowed. This is not looping. This is looping. I hope you have got the difference between what is looping and not. Fine. Dangling is not allowed. What is dangling? What is dangling? Just a minute. Yes. My dear friends, suppose you are drawing a network diagram and you have left a network diagram, you have left something like event hanging out in the middle. This is not allowed. This is not allowed. This is not allowed. You cannot leave an event like this hanging in the air. This is completely not allowed. So what you have to do? You have to ultimately connect it to the end part. This is called dangling. This is not allowed. You have to make it, you have to connect it to the end part. This is dangling. And finally, I have written stick to the given information. Now, why I have written this? This is not a rule, but this is just to inform you that unnecessarily do not introduce any dummy activities in your network. It will complicate your network. Stick to the given information, right? So better said than done. Whatever rules I have said, I know it is clear, but now we will take some examples and we will solve based on whatever rules we have studied over here. So thank you, Sandeep. Thank you. Now, very important, my dear friends, regarding the numbering of network, numbering in network diagram, most of the students, they leave this and they are very casual regarding numbering, but now I'll be explaining you how to number in a network diagram, right? The basic idea says what? The basic idea says that go from left to right, lower number should be on the left, higher number should be on the right. We always go from left to right. This is one basic intuition that you get. Second, you always go from 2 to 3. You don't generally come from 3 to 2. Generally, you don't come from 3 to 2 because higher to lower we don't come. These are the common intuitions, but let us discuss in general, in very clearly, what is Fulkerson's rule, or what is the rule that by which you can name an activity, name nodes. My dear friends, the only basic thing about this is you can only name a node which is having no incoming arrows. Yes, the rule says that you can only number an event where it is having no incoming arrow. You can only number that event which is having, it is event actually, we are here to number the nodes. You can only number that event which is having no incoming arrows, as simple as that. And then after that we will see what is to be done. Anyway, you just keep in mind Fulkerson's rule that we can only name something which is having no incoming arrows. Now I'll explain you further what is that. But before that, let us discuss how to draw this network diagram, and here only I'll be also telling you how to number the events. So activity A, okay. So I'll be using activity on arrow diagram, number A, fine. So let's say I've drawn this activity, it is having some days, I'm not writing any days, I have not given also, fine, this is ending. Now B, what is precedence relationship? Precedence relationship says that you cannot start something unless that is completed, right? It's something, it's similar to, you cannot have qualifiers in IPL unless and until group stages are done, right? So first group stage will come and then the qualifiers will come. I hope you got the point. So B cannot start until and unless A is starting. So I have already drawn A. So now I can start my activity B. So it needs to end somewhere. After B, C comes and precedence relationship is B, right? So from wherever B is ending, I am starting C. And wherever C is ending, I am starting D. Fine. This I have drawn the network diagram, and AOA is the method. Activity on node also I can do. That is not the important thing. I can directly do activity on node, and this is a simple one. That is fine. But first is how to number it. So generally what you will do, you will simply number 1, 2, 3, 4, 5. That is perfectly fine, no issues. But how to use Fulkerson's rule? Fulkerson's rule says that, now I will take you back to Fulkerson's rule. It says that you can only number that event which is having no incoming arrow. So over here, can you tell me which node or which event is having no incoming arrow? This one, right? This one. So you can number 1. After that what? After that it says that, just a minute, the burst event having no incoming arrow should be numbered at 1. We have already numbered that. Delete all the outgoing arrows from the numbered event. Now the second step is you have to delete it. You have to delete something. Let's say I have deleted this. Wherever I have done the numbering, I have deleted it. So now this event is having no incoming arrows, and I can number it, right? Why? Because Fulkerson's rule says that you can only number that event which is having no incoming arrow. Now since I have deleted it, this is having no incoming arrows, and then I can very easily number it as 2. and then I am completing this wherever I have done. Second step is what? You have to delete this. You have to delete this. Why? Because Fulkerson's rule says that you can only number that event which is having no incoming arrow. I have numbered this, and I am completing it. Similarly, you can number this 4. Similarly, you can number this 5. This completes our numbering. I know this is a very simple one. We have started with a simple one. I will tell you, we will do complicated problems also. So, good afternoon, Natul. Right. So, this I hope is clear. Second, my dear friends, this is the example number 2, and we will be seeing how to do it. Yes, Sandeep, dummy activity also we will see, that is not an issue. I will take an example after some time. After some time I will take an example where there is dummy activity also. Fine. So, my dear friends, activity on arrow I am taking. So, what is the activities? Activities are A and B, and what is the precedence relationship? There is no precedence relationship over here. So, I am taking a starting node. I am drawing activity A. I am drawing activity B. Now, activity C is having precedence as A. So, from A, wherever it is ending, start your C, and D is having, B. So, wherever activity B is ending, you can start your D. And E is having a precedence relationship of CD. So, wherever it is ending, you can start your activity E and you can end it. Right? Very easy. We have drawn it. My dear friends, now we have to number it. So, what does Fulkerson's rule says? Fulkerson's rule says that you can only number that event which is having no incoming arrows. Clearly, this event, only this event is having no incoming arrows. This is having, this is having, this is having, this is having. So, I will number it as 1. Now, the second step is you have to delete the arrows from the numbered event. Wherever I have done the numbering, I am deleting this. So, just assume I have deleted this. I am not going to erase again and again. Just assume I have deleted this. So, what is left? This one and this one is left. So, here and here are left, this and this are left, which is having no incoming arrows. So, as per Fulkerson's rule, you can number them. Now, I am numbering this as 2, I am numbering this as 3. You will have doubt that, sir, can I number this 2 and can I number this 3? Yes, it is possible. You can number whatever numbers you can. 2, 3, 2, 3, anything is possible. Fine. Second step is what? Whenever I have numbered them, I will delete the outgoing arrows from there. So, these 2 arrows are there. I am deleting this. What is left? This is left. No incoming arrows. I am numbering it as 4 and eventually I am numbering it as 5. So, now I hope that you are gaining some confidence while using Fulkerson's rule. Okay. Even if you don't use Fulkerson's rule and you simply name them as per your intuition basis, just based on whatever you feel is right, then also you would have numbered the same thing, I am guessing, right? Fine, but as of you just need to know what is Fulkerson's rule, and that's why I have explained you. Fine. Now, my dear friends, we are taking the example 3, and you will feel that this is a a slightly higher level problem compared to the previous one. How to draw the network diagram over in this question. Okay. So, first activities A, B are there and precedence relationship is nothing. So, let me draw, I am using activity on arrow. So, no precedence is there. So, I am starting A and then I am starting B. Why? Because A and B are having no precedence relationship. Now, come to C. It is having a relationship with A. So, wherever A is ending, I am starting C. D. Activity D is having a precedence relationship of AB. It means what? it means that until and unless this AB is getting done, you cannot start D. So let's say I have ended this B and I'm starting this D. But it should have A also. What to do? It should have A also. What to do? How can you draw now? Suddenly you are having problems in determining that from where you should start. From where you should start. From where you should start. Any idea? Any idea? Any idea? See, finally E is there and precedence relationship is having CD. So I can just end them and I can draw your E diagram, E activity. That is fine. That is the future one. But how to overcome this issue? So this is where, my dear friends, dummy activities comes into picture, right? This is where dummy activity comes into picture. You have to draw dummy activity. You have to draw dummy activity, else what will happen? C and D can have two similar common nodes, common start and common end, which is not allowed in any network diagram. My dear friends, so this is where I will have to show the dependence of D on A. So I will draw with a dotted line. So arrow also play a very important role over here. If you show over here, if you show arrow like in this way, so this is wrong. This is not allowed. Why? Because then C will have a dependency of A and B. So this is wrong. This is wrong. So what is right? You have to show the arrow in this way. So arrow plays a very important role as far as dummy activities are concerned. And now you can see, my dear friends, that D is having a relationship with A and B, and now everything is satisfying. Now, very important now, how to number the activities. How to number the activities, very important now comes into picture. First, I am numbering this as 1 because you know very well that I can number only those which is having no incoming arrows. So now I can delete. I have to delete this. I have to delete this. Now see, my dear friends, I have to delete this. So what is left now? This is left and this is left. No, I cannot say this is left now. Sandeep, yes, I cannot say this is left now. I have to number this first. Why? Because this I cannot number now. Why I cannot number now? Because it is having an incoming arrow. First I have numbered this, then I have deleted A and B. Why? Because incoming whatever arrows are going from 1 I have to delete. I have deleted. Now what is left? Only this is left. This is not left. Why? Because this is having an incoming arrow. I hope this is clear. I hope this is clear as far as dummy is concerned. So now I have numbered this. After that you have to delete whatever incoming is going. So these two gets deleted. What is left? This is not left. Only this is left. Why? Because it is having an incoming arrow. This is not left. Again you have to delete this. So this becomes 4 and this becomes 5. So I hope now that things are pretty much clear. This is the way of numbering the event and using Fulkerson's rule. My dear friends, so far we are only learning how to draw network diagrams. We are only learning how to draw network diagrams, and let me take you one more example. Let me take one more example, and after that I will be coming into your calculations of network analysis. Fine. So what to do over here? What to do? See, my dear friends, now in this question activities are given in the number format. How to draw them? Initially till now all the activities were given what? A, B, C in this way. Now it is given in the node format, that node 1 to node 2 in this way. So how to draw that? Let us quickly see this. Let's say I have drawn node 1 and 1, 2, 1, 3 is there. So somewhere there is 2 and somewhere there is 3. So I have joined them. This is done. 2 to 6. So 2 to 6, there is somewhere 6 around here. Now 6 can be here also, but let's say 6 is somewhere around here. 2 to 6 is there. 2 to 4. So 4 is also somewhere around here. So 2 to 4 I have drawn. 3 to 4, so 3 to 4 I have drawn. 3 to 5, somewhere there is 5 around here, so 3 to 5 I have drawn. 4 to 5, I have drawn 4 to 5, and 5 to 6, I have eventually joined 5 to 6. My dear friends, what are you observing over here? You are observing that it is so easy as compared to when it was not given in the number format. It was given in the alphabetical form, and then I have to I am drawing, and here I have drawn when it is given in the number format. So what is my experience? My experience is whenever they give you in this way, it is very easy to construct the diagram. No need of worrying about the numbering of the events, and everything is fine. You simply can name it A, you can simply name it B, C, D, E, F. That is not the issues, right? So you can get activities in this form also. Fine. Now my dear friends, I have taken a bigger question. And this will be the final example of drawing the network diagram, and let us try to see how to draw the network diagram. My dear friends, let me start. A, B, C is having no precedence, so I will be starting from here. Let's say I am starting from here. I will be keeping it short only because space is also less. So let's say this is A, this is B, this is C. My dear friends, let me tell you one thing, that don't expect that you will be drawing a perfect network diagram right from the beginning. Expect means if you have to erase something, be prepared for that. Fine. So A, B, C I have drawn. Now D is having a precedence of A. Fine. So wherever A is ending, I am starting D. E is having, now E and F both is having a precedence of B. So let's say B I have ended, and I don't know, I am just drawing E and F. I am not sure about the arrows also, but I am just going as per the information given. E and F is having a precedence of B. G is having a precedence of C. So let's say this is G. I am not connecting anything, I am just left it, I will just use it afterwards. H is having a precedence of D. Okay, so I have to end D now, and I have to start G. Fine. This is done. H is having a precedence of D. Sorry, this is H. Just a minute. This is your H. This is your H. Fine. I is having a precedence of E. So let me end this and let me start I. Done. J is having HI. HI, then they need to end somewhere, and then I have to draw J. Why? Because HI is the, means this is going some over here and merging. I hope you are getting it. And K is having F and G. So this is F, this is G. I have to end it, and then K is there. Now this is the end. So finally you can merge them in the single final event, right? So I have drawn it in a very short way, but I hope you are able to see how I have drawn the network diagram. Fine. Now how to number it? How to number it? Now I will be using Fulkerson's rule again over here, and if you have, and this question will clear beyond doubt that how to use Fulkerson's rule. I can name it as 1, no incoming arrows. After that, delete, delete, delete. These 3 are left, these 3 events are left. You can number as per your wish. 2, 3, 4, it's possible. 2, 3, 4, also it is possible. Let me name it 2, 3, and 4. What is the next step? Next step is, wherever you have done the recent numbering, you have to delete the arrows from there. So delete, 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 and delete. 1, 2, this 3, matlab D, E, F and G I have to delete. What is left? These 3 are left. These 3 events are left. So I can name it as 5, 6 and 7. After that what? Delete, delete, delete. Means H I have to delete, I have to delete K. H, I, K deleted. So how many are left? These you will feel that sir this and this are left. No, you can only have this as left. Why? Because this is having an j as, still it is having j as the incoming arrow. So 7, this is 8, and finally this is left, so this is 9. So now I think, my dear friends, that this clears beyond doubt that how to use your Fulkerson's rule, right? Fine. So is it clear till now? I hope things are very much clear as far as Fulkerson's rule is concerned, and about how to draw the network diagram and how to number them, right? So now, my dear friends, since we know now how to draw the network diagram, let us come to now analyze the network diagram. How to analyze a network diagram? And now, so before that, my dear friends, can you guess what is the answer? A dummy activity is artificially introduced, represented by dotted line, does not require any time, all of the above. So my dear friends, yes, it is artificially introduced. It does not consume any resources. You are drawing just to, yes, very good Sandeep, very good. You are drawing just to maintain the precedence relationship and does not require any time, represented by dotted line, artificially. Very good. D is the correct answer. Very good, very good. Yes. Now, my dear friends, after having cleared the basics of network diagram, now we are to do network calculation. And trust me, my dear friends, by this question itself, if you are understanding this question, how I am analyzing, you are free to do any question as far as your network calculation is concerned. You will never face any doubt. Yes. So let's try to understand how to do the network calculation. Fine. My dear friends, the first step is, first we will attack the nodes or events, and then we will take care of the activities. First I am going to consider the nodes, and then I am going to take care of the activities. Fine? Fine. Now how many nodes you are seeing over here? 1, 2, 3, 4, 5, 6. 6 nodes are there, and above every node there will be 2 time. I repeat, above every node there will be 2 time. First one I will write, and then after some time I will write the second time. What they are representing, I will tell you after some time. But first let us understand that how to calculate those times, right? I'll tell you what is the significance of each of those times, I'll tell you. But first what, and then why or how. So my dear friends, see one thing. I'm going to start from event 1, and whenever any event start, the starting time we take it as 0. So I've written 0, right? Now we will go from one node to other node, one node to other node, one node to other node. Whenever I am going to another node, you see that in how many ways I can reach that node, and you have to write the maximum time which is needed to reach that node. I repeat once again, my dear friends, that suppose on node 3 I am able to reach it in 2 ways. So I will calculate that how many ways I am going to reach that node and what is the maximum time in which I can reach that node, and I am going to write the maximum time as far as when I am going in the forward direction. Fine. So I can reach node 2 in only one way. So 0, I am starting at 0, and when you are reaching at node 2, activity A, you have to do it. Activity A is consuming 5 days, so 0 plus 5 will be 5. Fine. Now I have to reach node 3. In how many ways I can reach? I can reach in from 2 to 3, and then I can reach from 1 to 3. So if you reach from 1 to 3, it will be 0 plus 6, which is 6. And if I reach from 2 to 3, it will be 5 plus 3. Why I am adding? When you are going forward, you have to add the activity time, right? You have to add the activity time. So 5 plus 3 will be 8. So now you have two time estimates on reaching this node. So I told you that whenever you are going in the forward direction, you have to take the maximum time. So I will consider 8 over here, and that's why I am deleting these two. Let's try to go to 4. While reaching event 4, I only have one way, it seems, only one way, and that is 5 plus 8. 8 is the activity time of D. So 5 plus 8, it is 13. I have to reach activity 5, event 5. So how many ways I can reach? I can reach from 4 to 5. I can reach from 3 to 5. So when I am reaching from 3 to 5, it is 8 plus 2. I know these numbers are slightly blurry, but that's why I am reading it loud. This is 2, my dear friends, and this is a dummy activity. Yes, I have intentionally introduced a dummy activity also, so that everything is taken into consideration. So 13 plus 0 is 13. This is one way. 8 plus 2 is 10. So what is the maximum? Maximum is 13. So I am writing 13 over here. And now, my dear friends, the final node is left 6. In how many ways I can reach? I can reach from 3 to 6. I can reach from 5 to 6. I can reach from 4 to 6. 3 ways it's possible. You just add. First one, 3 to 6 is giving me 8 plus 11. 8 plus 11 is 19. 19. 13 plus 12. Yes, this is 12. This is 12. So 13 plus 12 is 25. So another option is 25. And then, my dear friend, 13 plus 1, the last one, 13 plus 1 is 14. This is 14. So what is the maximum? The maximum is 25. And I have written the 25 number. So now, my dear friends, this we have gone in the forward direction. The time which you have calculated for every node, we have done in the forward direction. That is why it is called forward path calculation. Forward path calculation. Fine. If you remember, we have one more time to calculate for every event. Now first what? First we have to learn how to do it, and then we will learn what is the significance of it. So first we have already done. Now this event I have written, we have, see, for forward I started with 0, I started from 1, and I ended up at 6. Now we have to come in backward direction. That's why now the time will be called, now whatever calculation you are doing, it will be called as backward path calculation. And now what you have to do, below this time, you just draw one line and simply write this time. Simply write this time 25. Simply write this time. Yes, I'm focusing on the mathematical part, but because why? Because I need to understand how to calculate everything. Now, my dear friends, from last event you have to come to the previous event till event 1, and now you have to see that while you are coming backward, in how many way it is possible, and while coming backward, now when you are going forward, you are adding the activity. Now when you will come backward, you will subtract the activity time, and if there are 2 ways on reaching in the backward direction, so you will write the minimum time. When you are going in the forward direction, you were writing the maximum time, and when you are coming in the backward direction, you will be writing minimum time, right? So when I am coming from 6 to 5, only one way by which I can reach this 5. Yes, only one way. Now don't say that, sir, this is also a way. From 6 I will go to 3, and 3 I will go to 5. This is not the way. In a straight line backward, which path is connecting, that you will write. So when you are coming 25 minus 12, when you are coming backward, you have to subtract the activity time. So 25 minus 12 is again 13, and below this 5 just write 13. This 13 and this 13. Fine. So after 5, let's discuss 4. Now, my dear friends, can you say or can you determine how many ways you are able to reach 4? Can you say how many ways we are able to reach 4? My dear friends, one way, and straight away from 6, there are 2 ways by which I can reach this 4. So you are already at 5, you are already over here. So if you come from 5 to 4, you have to subtract 13 minus dummy activity 0. So one is option is 13. One option is 13. Second option, when you are directly coming from 6 to 4, 25. See 25, this number which you have written, this denominator number, from there you have to subtract. So 25 minus 1, 25 minus 1 is 24. So what you have to write? You have to take the minimum number, minimum. Going forward maximum, going backward minimum. So 13 I will write over here. Let me erase this completely, and then I have to write 13 number. Now my dear friends, 4 is done, 3 events are done. Now let's attack event 3. In how many ways I am able to reach this 3? So one way, from 6 directly I am able to reach 3. Second way is 5. From 5 also, see 5 you are already there, 5 also, 3 is possible. Reverse, reverse, reverse. So when you are going from 6 to 3, 25 minus 11. 25 minus 11. 25 minus 11. What is 25 minus 11? 14. One option is 14. Another option is 13 minus 2. 13 minus 2. 13 minus 2 is 11. So which time you will write? Which time you will write? We have to write the minimum time. We have to write the minimum time, and so I will write 11 over here. Fine. Now my dear friends, we have to reach activity, we have to reach event 2. We have to reach event 2. So how many ways it is possible? How many ways it is possible? How many ways it is possible? Now see, 1 I am reaching in this way, 1 I am reaching from 4 I can come to 2, from 3 I can come to 2, 4 I can come to 2, from 3 I can come to 2. So if you come via this 11 minus 3, it is 8. And if you come via this, is it 13 minus 8? 13 minus 8 is 5. So which is the minimum? Which is the minimum? The minimum is 5. And so my dear friends, I have written 5 over here. And finally my dear friends, only this is left. So if you go from 2, it is 5 minus 5. It is 0. And another option is 11 minus 6, which is 5. So we have to take the minimum time. So 0 is the minimum time. And in this way, I have done, or I have written all the time estimates. In this way, I have written the time estimates. In this way, I have written the time estimates, my dear friend. Is it clear? Tell me. Is it clear, my dear friends? Tell me. Is this clear? Is this clear? Tell me. Is the time estimates clear? Now, is it clear? Tell me. First confirm. Is it clear or not? First check. I suggest you to check everything, how I have drawn the how I have calculated the time estimates. Fine. Now, if this is clear, my dear friends, what this is representing, it is very important to know what these are representing. Now, forward time, when I am going in the forward direction, the time that I have evaluated, that is giving me the earliest time in which I can reach an event or in which I can complete the event. And whenever I am going in the backward direction, it is giving me the latest time in which an event can be done. Latest time in which an event should be done while not, disturbing the total project duration. Now, this event can be done earliest in 25, latest in 25. Means this event can be reached in 25 days. And when you have reached the event, you have done the activity. You have done the entire project. Yes or no? I'll come to the project later on, but now we are focusing on the event. Now we are focusing on the event. So I repeat again, when I am going in the forward direction, I am getting the time which is written in the numerator, and that is giving me earliest time, earliest, early to early, early as early as possible. Someone says, now you have to reach that event as early as possible. So I can do this event 3 as early as 8 days. Before that I cannot do. Next, what is 11? 11 is I can do this event 3 as late as 11. As late as 11. I can do this as late as 11. I can do this as late as 11. Now there must be some limitations. Na? The limitation is without violating the project duration. Without violating the project duration. So I can do this event 3 as early as 8. I can do this event 3 as late as 11. So what is the relaxation time, my dear friends? Now from here only we get the concept of relaxation time. What is the relaxation time? Relaxation time is 11 minus 8, 3 days. And that relaxation time is known as, my dear friends, slack of an event. That relaxation time is known as slack of an event. Yes, I need to use the word slack. What is slack? What is slack? Slack is the relaxation time when we are doing a particular event, right? So what is the slack for event 1? 0. Slack for event 2? 0. For 4, 0, 5, 0, 6, 0. So many events are having 0 slack. Only event 3 is having a slack of 3 days. 3 days means you can relax, you can chill, you can go to Goa for 3 days as long as your project duration is not getting affected. Project duration, that is 25, is not getting affected. Now I'll come to project duration. Wait, but as of now you understand that okay, this is the project duration that we are talking about. Fine. So till now, my dear friends, we have talked about event. We have focused only on event. Yes or no? Our focus was only on event, that I can do event this. Always I am taking, talking about event. But now I will talk about activity also. Now I will talk about activity also. And now we should talk about activity. My dear friends, for that matter of fact, I am so forward pass calculation, backward pass calculation, everyone knows. Yes, we have discussed it very nicely. And we can very easily calculate that. I've already discussed this also. Fine. So now, my dear friends, now we have to evaluate an activity, and for that I am writing again. It was 0, 0. It was 5 and 5. It was 13 and 13. It was also 13 and 13. It was 25 and 25. And this was 8 and 11. 8 and 11. Right? Now, my dear friends, we have to analyze the activity. So let us try to analyze what about an activity. Dekho. So if I have to analyze an activity, I have to pick up some activity. Let's say I am picking up activity E. Let's say I am picking up activity E. E is taking 2 days. This is the event 3, this is the event 5. So this is your 8 days, this is your 11. This time I am writing in this way, and for 5 it is 13 and this is 13. Fine. This is 13 and this is 13. My dear friends, see, for an activity, before calculating the relaxation, there are 4 types of times which is possible for an activity. For example, what is the earliest finish time for an activity? What is the earliest start time? What is the earliest start time by which you can start an activity? What is the earliest finish time for an activity? What is the latest start time for an activity? And what is the latest finish time for an activity? These 4 types of time they can ask you in examination, and let us discuss one by one. EST, EFT, LST and LFT. I hope you are getting earliest start time, earliest finish time, latest start time, latest finish time for an activity. And my dear friends, let me tell you, in last 2-3 years only if you check out the paper, they have given you a network diagram and then they are asking you any of these times. Yes, so you have to be very careful as far as this is concerned, right? Is it clear so far? 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 Yes. Now my dear friends, see, these two time estimates for an event you have already done. These two time estimates for event you have already done, and see, your efforts will be saved now when I am calculating these times. You have done these for event, yes or no? You have done these calculations for an event, and see automatically how activity is also taken care of by what I am going to say. Directly from this figure, you will be getting 2 times out of these 4. Your target is to calculate 4. From here, directly 2 will be calculated. How? Dekho. Just see what I am circling. I have circled 2 numbers. One is 8, one is 13. So 8 is given by this EST. EST is this number. LFT is this number 13. Means directly from here you are getting 2 times. This is giving your EST. This is giving your LFT, latest finish time. Without any hard work, you are getting 2 types of time. Now tell me one thing. Let's say you have started your preparation early. So will you also let's say I am giving you an example and very easily it will be done. Let's say for finishing a subject you are taking or finishing a chapter. Let's say for finishing a chapter you are taking 2 days. Today is, let's say 31st. Chalo theek hai. You have started your preparation on, you have started your subject on 1st June. So you will complete this by 3rd June. You will complete this by 3rd June. ठीक है. And so if you are starting on 1st June, you will be completing this by 3rd June. ठीक है. Let's say you are starting this by 5th June. So you will be completing this by 7th June. You will completing this by 7th. Before starting of 7th June only you will complete 5. You have started 5 and 6 you are complete. Like before starting 7th June also only you will complete. You are not going to take 7th also. You are not going to take 6th also. Before that only you will be finishing this. So when you are starting on 5th June, so what you did? You have only added this 2 days. This 2 days will be constant only. So you are just simply adding 2 days and then 3rd is coming. You are simply adding. So what is the logic? Logic is that if you are starting something early, you will finish also something early. And when you have finished late, you must have started late. So the concept is when you are starting early, earliest start time, you will finish also early. How you will finish? You will simply add the activity time. The activity time is 2. So 8 plus 2 is 10. And when you have finished something late, you must have also started something late. So how will you get the latest start time? Simply reduce the activity time, simply subtract the activity time, and that is 13 minus 2, and that is 11. So very simple logic. I have this in front of me. Directly I will calculate directly I have the 2 time estimates, EST and LFT from the diagram. You add activity time on EST, you get EFT. You subtract activity time from LFT, you get LST. And similarly, for every activity, you will get these 3 time estimates. I hope now that this is very much clear. Right? I hope now that this is very much clear. Right? So you can do this very easily, right? So for example, if I consider activity F, if I consider activity F, so this 8 is my, let me use it a different pen. This 8 is my earliest start time. This 25, now I am considering event activity F, this activity. So this 25 is my latest finish time. You subtract LFT, 25 में से if you subtract 11, you get 14. So 14 becomes your LST. And if you add EST में 11, 8 plus 11, so earliest finish time will be 8 plus 11, 19. So similarly, you can do every calculation as far as your activity is concerned, right? So I hope the concept of these 4 time estimates are crystal clear. And now, my dear friends, let me do the final calculation, and that is so EST done, EFT, LST, LFT, this is also done. Earliest finish time can be regarded as, so EST plus duration, this is done, right? And now, my dear friends, the final discussion is what is the float of an activity, So for that matter of fact, I will also consider the same activity E. I will also consider the same activity E. So this is my activity E. So let me see what is the for 8, 8, 11, 13, 13. This is was your 8, 11, and this is 13, and this is 13. Duration was 2 days. Duration was 2 days. This is 3, this is 5. Don't get confused, but I am not numbering the notes as of now, as you might get confused. So no need to write notes. I am just numbering the, I am just written only those numbers which I have calculated. Now, my dear friends, there are two things, there are in fact 3 things that we need to find out. One is total float of an activity. One is free float of an activity. And one is independent float of an activity. These are the 3 floats. What is float? First of all, what is float? See, for event, you calculated the relaxation time which is needed for an event. Means how much relaxation time, how many days I can take an off and go to Goa. Similarly, in activity also, there must be some relaxation time. That what is the relaxation allowed for doing this activity? Means for how many days I can take a break and go to Goa and chill around. So that is the float. Now, total float for an activity, how many total relaxation I can take? This is the total float which I will be calculating. Similarly, free float and independent float is also having some, implications. What are implications? I will talk about it later. But first of all, what? First of all, we have to need to know what is how to calculate, and then we will see what is the significance. It will be very funny if you know the significance and you don't know how to calculate. Fine. So my dear friends, there is a particular formula for calculating the total float, but I will give you one simple diagram, one simple line diagram, and then you will be able to find how to calculate the total float. And that way is, my dear friends, just a minute, changing the color. Simply draw this diagram and you will be calculating the total float. How? You started from 13, write 13. And wherever your arrow is passing the numbers, you simply subtract them. It is passing from 2, it is passing from 8. So minus 2 minus 8. So 13 minus 10 is 3. This is your total float. There is a particular formula. I know there is a formula. This is what? This is your LFT minus activity time minus EST. I know this is the formula, but if you follow this way, you can easily find what is the total float. What is the free float? Free float is total float minus head slack. total float minus head slack. So total float is 3. What is the head? See, for this activity, this is the head event, right? Head event A. So what is the slack? Slack is 0. So total float is 3 minus head slack is 0, and that is 3. Done. What is independent float? Independent float is free float minus tail slack. So total free float is what? 3, and what is the tail slack? Tail slack, what is the slack of this tail? Tail event ka slack kitna? 11 minus 8, which is 3. So 3 minus 3 is 0. Done. 3 minus 3 is 0. So very easy, my dear friends. Total float, you just draw this. Total float you got. Free float, matlab total float minus head slack, done, and independent float. Now what is free float and independent float are representing? You just have to remember that these are representing that by how many days you can delay an activity without affecting the successor activities and without affecting the predecessor activities. As simple as that. Without affecting the successor, which is after that particular activity, and what without affecting the previous activities. Fine. Now my dear friends, like this we will be calculating the floats of every activity. Now my dear friends, you have the diagram with you. If you calculate the total float, free float, independent float for ADH. Now why I am writing ADH? There is a particular reason. For ADH, you will find that everywhere you are getting 0. If you calculate the floats for any of the activities ADH, you will find that everything you are getting 0. Slack be 0, head event slack, tail event slack, total float, independent float, everything you are getting 0 for these particular activities. So such activities are known as critical activities. What is meant? See, we already discussed that slack and float is representing the relaxation time. And when you are saying that it is when these two times are same, let's say when your total slack is coming out to be 0, it means you cannot chill out. You cannot afford to waste any time. When I am saying the total float for an activity is 0, what it means? It means that you cannot chill out. You have 0 days to chill out. If you chill out, your project will be hampered. You go to Goa, you go anywhere, but if you go, your project will not be able to complete it in this 25 days. So it means you have 0 relaxation, and it means that those activities are very much critical as far as your project needs to be completed. So that is why critical means what? Critical means something very important. You cannot afford to lose any day on that particular activity or on that particular event. So such activities are known as critical activities. Critical means you cannot afford to lose any day. You cannot afford to chill out. You cannot afford to relax any day as far as those activities are concerned. And my dear friends, the path on which these critical activities are lying, that path is called as critical path. The path on which those activities are lying are known as critical path, and if you add the duration of the critical activities, you will be getting the duration of the critical path. Yes or no? So my dear friends, this is the conclusion. This is the conclusion of the entire discussion, my dear friends, that so for ADH, so what is the critical path of a network? The path on which critical activities lie is called critical path, and the duration of the critical path, the duration of critical path is called critical path duration. Critical path duration. So what is critical path duration? Critical path duration is the minimum time in which you can evaluate the or which you can complete the entire project. If someone, yes, I asked you in the beginning of the video, I told you that after this, after the discussion, you will be able to tell that what is the minimum time in which you can complete the entire project. Minimum time. So this is the minimum time. What? Critical path duration is the minimum time by which you can complete the project. Now, there are so many questions based on critical path which you will be getting almost every year as far as your GATE is concerned, right? Now, my dear friends, you will be thinking that, sir, don't you think that this is very much lengthy? First, you have to calculate every time. You have to calculate the 2 time estimates. First, you have to calculate the 2 time estimates for every event. Then you have to calculate slack. Then you have to calculate for activity. We have to calculate the float, then total float, so many things. And then we will see that when they are going to be 0. And then we will see that on which path they are lying. And then we will say that the critical path. So don't you think that this is very much tiresome? And if they simply ask you what is the critical path duration, we will do this thing and then we will say that okay, this is the path on which all these activities are lying, and that's why they are the critical path. So sir, there must be some very easy way of calculating the critical path. The easy way is from beginning to end, you calculate, you find out you figure out all the path which is leading from 1 to 6. You calculate the time which is required to complete from whatever activities are lying. You just add all those time and you will be getting one time duration. So many time duration you will get. So first figure out how many ways you can reach from beginning to end. Then you calculate the time for every path. Let's say there are 2-3 paths. From there, select the path with the maximum time duration. That will give you the critical path. So I repeat, my dear friends, from 1 to 6, let's say 1, 3, 6 is one way, 1, 3, 5, 6 is another way, 1, 2, 3, 5, 6 another way, 1, 2, 4, 5, 6 another way, 1, 2, 4, 6 another way. There are 4-5 ways of which I can reach from 1 to 6. Let's say I calculated the time for every path, and then I will say which is the maximum path, maximum time. So let's say as per our analysis, as per our analysis, we concluded that A, D, and H are the critical critical activities, and hence it is the path on which they are lying are the critical path. So calculate the time. 8 plus 5, 13, 13 plus 12, 25. So 25 should be the critical path duration. So let's say I am checking out the first one. That means 1, 3 and 6. So 11 plus 6, 17. 11 plus 6, let's say 17. Then 1, 3, 5, 6. So 6 plus 2, 8. 8 plus 12, 20. 17. One option is 20, one option is 17. Then 5, 3, 8, 8 to 10. 10 and 12, 22. One option is 22. So many options are there, but 25 is my answer because it's the longest path in the network. So what is the conclusion? Conclusion is whenever you get a diagram and then asking you critical path, you evaluate, you figure out how many paths are there, you calculate the time from beginning to last, you calculate all the times, you see which is the maximum one, that becomes your critical path. Sir, if there are more than one critical path, suppose I am getting 20 and 20, so it's fine, there can be more than one critical path in your network, that is not an issue, fine, right? So my dear friends, let me conclude whatever we have learned today. The thing is, whenever you are given a network diagram or network model, they can ask you critical path, they can ask you what is the slack of an event, they can ask you what is the float of an event, they can ask you what is the EST, EFT, LST, LFT, these 4 time estimates they can ask you for any activity. So within this only they will be asking you as far as your network diagram is concerned. And I hope that you have understood it very neatly, right? For any kind of doubt, you can leave in the comment section and I will be answering you. That is not the problem. So I hope that you have got the entire analysis. Any doubt you can ask, right? So my dear friends, this fundamental series that we have started, tomorrow I will be discussing the concepts of PERT. This is the CPM, critical path method. Tomorrow I will be discussing the basic concepts of PERT and the most important distribution in your industrial engineering is normal distribution, and tomorrow I am going to address the normal distribution, and I will tell you that in which chapters this normal distribution is applied, right? So try not to miss tomorrow's class on fundamentals. I will be discussing normal distribution and I will tell you that where this is applied and how they use normal distribution in evaluating your any particular topic. So that's it today, my dear friends. That's it from now. I hope you have enjoyed the session. If you are finding this useful, share it with your friends. Let them know they can also attend, and in case of any doubt you can leave it in the comment section. So thank you very much, my dear friends. Thank you very much. Let us meet tomorrow.